Okay, we have done the quadrant. Now, some other trigonometric useful angle, not exactly complementary angle stuff, but other stuff when transitioning from one quadrant into another, that will help us to use in the other examples and questions. We already know about the complementary angles, and sine of 90 minus a will be cos a, cos of 90 minus a will be sine a, and that stuff. So let's do for the plus. Now we get sine of 90 plus a. See, since it is sine, just remember it this way. Since it is sine goes into the second quadrant. 90 plus something is in the second quadrant. The second quadrant sine is positive, but since it is 90 plus, it changes to cos. Similarly, cos 90 plus a. Now, since it is cos goes into the second quadrant, but since cos is negative, this will be minus of sine a. Tan again 90 plus a. Tan goes into the second quadrant, it becomes negative. It will be minus cot a. Similarly, for the reciprocals, let's see what happens if we add this was all pi by 2. Okay, let's talk now from now onwards only in terms of radian, that is in terms of pi. So what happens if we go sine pi plus x? Now pi is 180 degree. So we have crossed the first quadrant, we have crossed the second quadrant, we are going to the third quadrant. Sine is positive only for the both above quadrant 1 and 2. In the third quadrant it is negative. Sine goes negative, but it stays sine. Alright, so you need to remember that whenever we take an odd multiple of pi by 2 and add or subtract, we get that it changes from sine to cos, cos to sine, tan to cos, and accordingly and we set this negative or positive according to which quadrant it goes in. But when it is even multiples of, when it is just multiples of pi, even multiples of pi by 2, we see that sine stays sine, cos stays cos and all. You just have to care for the positive and negative sign. Now again cos pi plus x. We see that in the third quadrant cos is also negative because cos is positive in the first and fourth quadrant, not in these two. So it becomes minus cos x. But tan is positive in the first and third quadrant. So tan pi plus becomes tan x. Now let's do for negative. Suppose we were subtracting from pi. Now sine pi minus x. We know this becomes in the second quadrant, so sine stays positive, and since it's even multiples of pi by 2, multiples of pi, we get sine x. Cos pi minus x, similarly we get minus cos x. Tan pi minus x, we get minus tan x. Alright. Similarly for 3 pi by 2, sine 3 pi by 2 plus a. This will give us 3 pi by 2 changes it into cos, and since it goes into the fourth quadrant, sine is negative, minus cos a. See, it goes into the fourth quadrant. I know it can be confusing because cos is positive in the fourth quadrant, but always look at the LHS. Since sine is getting assigned 270 plus an angle, okay, so 270 plus angle becomes sine in the fourth quadrant, but since sine in the fourth quadrant is negative, the RHS also has to be negative, and A is obviously an angle between 0 and 90 degrees, 0 and pi by 2, so it will always be positive for all their trigonometric ratios. Continuing like this, cos 3 pi by 2 plus a gives us, it is the fourth quadrant, cos is positive, it gives us sine a. Tan 3 pi by 2 plus a gives us minus cot a. Subtracting sine 3 pi by 2 minus a gives us third quadrant, sine is negative, it turns minus cos a. Again cos 3 pi by 2 minus a gives us minus sine A, but tan 3 pi by 2 minus A gives us cot A, because tan is positive in the third quadrant, so it does not turn negative, but since it is an odd multiple of pi by 2, it turns into cot. Let's do the final for 2 pi. Sine 2 pi plus x gives sin x. Everything after 2 pi and x belonging between 0 and pi by 2, it comes into the first quadrant. In first quadrant, everything is negative. 2 pi is an even multiple of pi by 2, or a multiple of pi if you prefer, and so it sign does not change into cos. Okay. Similarly, cos 2 pi plus x equals to cos x, and tan 2 pi plus x equals to tan x. Alright, let's do for subtraction. Sine 2 pi minus x, this will be minus sin x, because it's in the fourth quadrant. 2 pi is this line 0 degree, but 360 degree as well, so anything below it is in the fourth quadrant. Again, cos 2 pi minus x will be cos x, because it is in the fourth quadrant, but tan will be negative. Alright, these are some stuff you have to remember as well to get your negative and positive and also the conversions right. We can generalize this to a more specific thing, that is sine 2 and everything. This can be generalized pretty easily. Sine, cos, tan, pretty much everything. 2 and pi plus any angle gives the same. Sine, cos, tan, theta. Okay. The rest can be generalized in a similar fashion if you try, but I would suggest that if you are given really large angles, try to break them up into multiples of 360 and then proceed from there. Suppose you are given an angle like 540. Now 540 equals 360 plus 180, 2 pi plus pi. Now we have 3 pi. See, let me draw. This is 2 pi and this is another pi. So we are at, this is pi by 2. This is another pi. 3 pi. We have circled 3 pi times, and now we have to check whether it's this side or this side, and accordingly we can provide. Okay. Another thing which might not have been clear or might have been confusing because it was not explicitly mentioned. See, since we generalized sine 2n pi plus x equals to sine x, sine 2 pi minus x, let's do that. Sine 2 pi minus x was what? Minus sine x. We generalize it to 2n pi as well, so we get sine 2n pi minus x equals to minus sine x. Now n belongs to integers, so n can be 0 as well. So what is sine 0 minus x? It's basically sine of a negative angle. Sine of negative angle gives minus sine x. Similarly, in the case of cos, 2n pi minus x was just cos x, so cos of negative angle is just cos x. Alright, and tan, since it is the the fraction of these two, it will be minus tan x. This is pretty clear from the graphs as well, because when we see the graphs of sin x goes like this. It is positive here, but it is negative here. So when it is negative, it is negative of this value. Suppose both here are pi by 3 but minus. These values, absolute value will be equal, but the sign will be different. But cos, it goes like this. So whatever the value is here, the value is also here. Alright, and that goes on for eternity. Similarly for tan, if you draw the graph, you can see it pretty clearly. Some more of the stuff. Let's talk about the domain and range. Now, do we know what a domain and range is? Suppose we are given any function fx. Fx equals to root over of x minus 1 divided by, suppose, x plus 1. Okay. So how do we find out what is its domain and range, and how do we find that out? See, the thing is that domain means for what possible values of x will the function fx be defined. Now fx obviously can't be defined if suppose x plus 1 is 0, that means x equal to minus 1. So that value is accounted for. X cannot be minus 1. But it also cannot be defined if this whole thing is negative, because root over of a negative gives us an imaginary number, and we are dealing with real numbers here. So we have that x cannot be minus 1 in terms of the denominator, and then we have x minus 1 divided by x plus 1 must be greater than 0. Now since we don't know what sign x plus 1 is, we cannot just multiply it by both sides and get that x is greater than 1. So we have we multiply x plus 1 whole square. Since it is positive, it gives us that x minus 1, x plus 1 greater than 0, which means x square minus 1 is greater than 0, which means x square is greater than 1, which means mod of x is greater than 1. That is, either x is less than minus 1 or x is greater than 1. See, this does not seem likely, but put any value which is less than minus 1. Suppose you put minus 5. You get minus 5 minus 1 divided by minus 5 plus 1. This is minus 6 by minus 4. This cancels. We get 3 by 2, and its root is rational. Here's how we find the domain. Okay. What about the range? We need to find out what values this function can give us. While plotting its graph, what values on the y-axis can we easily get? To find that, we have to write these in terms of, let's suppose this function fx, we call it y because it gives us an outputs on the y-axis. We have to write x in terms of y now. So x minus 1 by x plus 1, we get y square equal to x minus 1 by x plus 1. Now, x minus 1 equals to y square x plus y square, x 1 minus y square equal to y square plus 1, x is equals to y square plus 1 divided by y square 1 minus y square. Alright, we find that this is x, but how can this give us the range of values that y can accumulate? We find it from the domain. Now we know that x is not equal to minus 1 and mod of x is greater than 1. We fit the value of x, that is this thing, into this, and we get the range. What values can it satisfy? I hope this example was good to clear the concept of domain and range. So let's move on to the domain and range of the trigonometric ratios. Alright. Okay. So sine and cos, they both have the same domain and range. Their domain is equals R. This symbol is used to denote the set of all real numbers. See, pi, radians are basically a measure, but they are basically real numbers. Pi is just used to denote 180 degree. Pi in real life, as we know, is 22 by 7, and that is a real number. The domain is all R because they can take any value and still give a plausible output. But the range, they only give us values in the range -1 to 1. Okay, These brackets are used to indicate that the range is between -1 to 1, but it also includes -1 and 1. Okay, let's go for sec, cosec, tan, cot. They are a bit different. Let's see for each. Let's go for tan only first. Tan. Alright. Now, what do we know about tan? Tan cannot give us a defined value when cos is negative. Where is cos negative? At odd multiples of pi by 2. So tan's domain becomes r minus odd multiples of pi by 2, because then it is not defined. Okay, but the range, tan can give us any value from -infinity to infinity, as we see from the graph. Since it also repeats, that doesn't matter, but if we take any continuous line on the graph, it gives us all the values from -infinity to infinity. Okay. For cot, we have the opposite. Minus, wherever sign is negative, it cannot give us defined values. Where is sign negative? At values of at integral multiples of pi, and but its range, similar to tan, is -infinity to infinity. Alright, see, this is done. Let's go for sec and cos. Sec is 1 by cos, so its domain will be the same as tan, but its range, cos is only gives values in -1 to 1. So since it is the reciprocal of sec is the reciprocal of cos, sec will only give values in -infinity to -1 and 1 to infinity. We can also write it as r minus -1 to 1. You will learn the use of these brackets in other chapters. For now, just understand the concept that they give values in this range, and they cannot give values at all radians. For cosec, the domain is same as cot, and the range is same as sec. Now, since we have gone over the domain and ranges as well,